True projects. In this video, we are going to explain about the project title Credit Card Fraud Detection Using Machine Learning. Before diving into the execution, let me give you an overview of the project. Credit card fraud refers to unauthorized transactions made by using stolen or counterfeit credit card information, resulting in financial losses for consumers and merchants. This project focuses on addressing credit card fraud, a significant concern in the financial sector, by developing an efficient fraud detection system. Existing methods, rule-based systems, and basic anomaly detection algorithms often struggle with high-dimensional dataset and may suffer from overfitting due to irrelevant features. These limitations necessitate the exploration of advanced techniques for improved accuracy and efficiency. To address these limitations, the proposed system in the base paper integrates advanced machine learning algorithms like LightGBM, XGBoost, gradient boosting, and HPBoost. Based on patterns and anomalies found in the transaction data, these algorithms automatically learn from past transactions to identify fraudulent activity. Additionally, the project extends its capabilities by applying ensemble methods, specifically the voting classifier, which combines the bagging classifier with random forest and decision tree techniques, thereby enhancing prediction accuracy. The system aims to classify transactions into two categories: legitimate, non-fraudulent, and fraudulent, using machine learning models trained on transaction features. Evaluation metrics such as accuracy, precision, recall, F1 score, geometric mean score, and area under the ROC curve are employed to assess the system's effectiveness in correctly identifying fraudulent transactions while minimizing false positives. Ultimately, stakeholders, including credit card companies, financial institutions, merchants, and cardholders, stand to benefit from reduced financial losses, chargebacks, and improved security, thereby improving trust and confidence in credit card transactions. To implement this project, we need software and hardware requirements. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used. These are the algorithms built in the project. The first four are the algorithms which are proposed in the base paper, which are LightGBM, XGBoost, gradient boosting, and HPBoost. And this is the algorithm which we have proposed to further improve the performance for detecting credit card fraud. We have built all these algorithms to compare the performance with different evaluation metrics like accuracy, precision, recall, F1 score, geometric mean score, and area under the ROC curve. So here we have deployed voting classifier in the front end. So now let me explain you what voting classifier is. A voting classifier is an ensemble learning technique that combines the predictions of multiple base classifiers to make a final prediction. It aggregates the individual predictions by majority voting or averaging the class probabilities to determine the final classification outcome. Voting classifier is employed to enhance the credit card fraud detection system's performance. It combines two base classifiers, a bagging classifier with a random forest and a decision tree classifier. The bagging classifier with random forest is configured to reduce overfitting by creating multiple subsets of the data and training several instances of the random forest classifier. The decision tree classifier operates independently. The voting classifier is trained on the training data and used to predict the classes of transactions in the test dataset. Now let us execute the project. To execute this project, first we need to open the code folder which contains the project source code files. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, home.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And here, this is the credit card data set. Let us open this. This is the credit card transaction data of the customers. And here, we use this data to train all the algorithms to detect credit card fraud. And here, these are the parameters named as V1, V2, V3, V4, and so on, just for the security purpose. And here, we have the target variable in which we are having two classes, 0 and 1. 0 is non-fraudulent and 1 is fraudulent. So based on these transactions, we will predict whether it is a fraudulent activity or non-fraudulent activity. Now let us close this data and go back to the code folder. And here, this is the test cases file. These are the test cases which we will use during the execution. So here again, we have the parameters which are named as V3, V4, V7 for the security purpose. And here we have the target variable with 1 and 0 labels, where 0 is non-fraudulent activity and 1 is fraudulent activity. So depending upon these transactions, we will predict whether it is a fraudulent activity or non-fraudulent activity. Now close this data set. Now copy the path of the code folder from the address bar of the file explorer. Here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up link here. So here we need to enter all these details to register. But I have already registered. So click on sign in. So here we need to enter the username and the password, which are static, and then click on sign in. We have logged in successfully and we are redirected to the prediction page. So here we need to enter the values of these parameters, and after entering the values, the application will predict whether it is a fraudulent activity or non-fraudulent activity. So let us enter these values from the test cases which are present in the sample file. So here from the sample folder, I'm entering the values. So the first one is V3, which is minus 5.140, V4, which is 1.411303, V5, which is minus 1.690, V7, which is minus 3.65, V10, V11, V12, V14, V17, V20, V26, and the time is this. The amount is 80.22. So based on these values, the application will predict whether it is a fraudulent activity or not. Click on predict button now. So here we can see the result, fraudulent transaction based on the inputs provided. So it is a fraudulent transaction. Let us enter another set of parameters from the sample data set. Click on prediction link here again. Let us enter the values. So here V3 is 2.188, V4, V5, V7, V10, V11, V12, V14, V17, V20, V26, time, and the amount, which is 30.53. Now click on predict button. So here we can see the result, non-fraudulent transaction based on the inputs provided. So this is a non-fraudulent transaction. It means that there is no credit card fraud detected. Let us enter another set of parameters. So click on prediction link again. So again, from the test cases, let us enter. So here the V3 is minus 1.76. V4 is 4.833. V5 is minus 0.26. V7 is 1.140. V10 is 0.08. V11 is minus 0.000121. And V12 is minus 0.054. V14, V17, V20, V26, time, and the amount is 723.21. And here we can see the class label, which is 1. It means it is a fraudulent activity based on the input provided. So now click on predict to check that. So here, this is the result, which is fraudulent transaction based on the inputs provided. Let us enter another set of parameters. Click on prediction link. Again, from the sample data set, we need to enter the test cases. So let us enter this test case V3, V4, V5, V7, V10, V11, V12, V14, V17, V20, V26, time, and the amount is 57. And here we can see the class label, which is 0, which means that it is a non-fraudulent activity. Click on predict to check that. So here we can see the result, non-fraudulent transaction based on the inputs provided. In this way, by entering the values of the parameters, we can predict whether it is a fraudulent activity or non-fraudulent activity. Now click on graph link. So here we have the sample outcome graph, which displays the distribution of labels. So here on the x-axis, we have the class label 0 and 1, and on the y-axis, we have the count for that. So here we can see that 0 is having the maximum count. So here the 0 means non-fraudulent activity and 1 means fraudulent activity. And here we have the correlation matrix. And here we have the comparison graphs for the evaluation metrics: accuracy, precision, recall, FN score, G mean, and AUC score. So on the x-axis, we have the score for the evaluation metrics, and on the y-axis, we have the algorithm name. And the algorithm which is performing best will be used for prediction. So in this project, we have deployed voting classifier in the front end. Click on sign out link here. So we have built a system that predicts whether fraudulent activity is detected or not based on the parameters. Detecting fraudulent activities is crucial because it helps protect both financial institutions and consumers from significant losses and damage.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.